Alright, in this video we're going to talk about integration of powers of trig functions. For more information, visit calculuswithoutlimits.com. So we're going to start with the simplest case involving sine and cosine functions squared. In these cases we can simplify the integrand using the trig identities. Sine squared of x is 1 minus cosine 2x over 2. Cosine squared of x is 1 plus cosine 2x over 2. And sine squared plus cosine squared equals 1. So we'll start with the simplest example of all, the integral of sine squared of x dx. This is easy to do using basic trig identities, and we'll call upon sine squared of x is 1 minus cosine 2x over 2. So we can rewrite the integral of sine squared of x dx is the integral of 1 minus cosine 2x over 2 dx. Now we use the integral of f plus g is equal to integral of f plus integral of g, and we can split that up into the 1/2 the integral of dx minus 1/2 integral of cosine 2x dx. Now the integral of dx, of course, is just x. So now let's focus on the integral of cosine 2x. We take u equals 2x, so we're going to do u substitution. So u is 2x, so du is 2dx. So the integral of cosine 2x dx becomes 1/2 the integral of cosine u du, which of course is just sine of u. Putting everything together, the integral of sine squared of x dx is the integral of 1 minus cosine 2x over 2 dx is 1/2 integral dx minus 1/2 integral cosine 2x dx is 1/2 x minus 1/4 sine 2x plus c. And you get the 1/4 there because there's an extra 1/2 from the u substitution we did on the last integral. So let's try something a little bit more challenging. This time we have the integral of sine to the 5th of x dx. To do an integral like this, we start by pulling off one of the sine terms. Sine 5th of x equals sine 4th of x times sine of x, which is sine squared of x squared times sine of x. So whenever you see sine raised to an odd power, peel off a sine term and then try to get sine squared of x raised to some power. So we recall the most basic of identities. Sine squared of x is 1 minus cosine squared of x. So we can rewrite everything in the following way. The integral of sine to the 5th of x is integral of sine 4th of x times sine of x is integral of sine squared of x squared sine of x is the integral of 1 minus cosine squared squared sine of x dx, where we use sine of x squared plus cosine of x squared equals 1. Now we can do the integral with u substitution. We take u equal cosine of x, so du would be minus sine of x dx. Now we already have the sine of x in the integrand, so we need to pull a minus sign on the outside because the derivative of cosine is minus sine. And so we get minus the integral of 1 minus u squared squared. So we just multiply that out, and that becomes minus the integral of 1 minus 2u squared plus u to the 4th. And integrating term by term, we get minus u plus 2/3 u cubed minus 1/5 u to the 5th plus the constant of integration. Now to get the answer, we just go back to u equals cosine of x. And so the integral of sine to the 5th of x is minus cosine x plus 2/3 cos cubed of x minus 1/5 cosine 5th x plus c. Alright, now let's try another example. This will be our front example for this video. It's basically the same, but we've already got a cosine term in here, but we've also got an odd power of sine. So once again, peel off one of the sine terms and then use the trig identities to eliminate powers of 2. So we start off with the integral of cosine fourth x sine cube of x dx is integral of cosine fourth x sine squared x times sine x dx. So we just pulled off one of the sine terms. Now we're going to get rid of that sine squared by using sine squared plus cosine squared equals 1. So that becomes the integral of cosine to the fourth times 1 minus cosine squared x sine x dx. Now we're going to pull the cosine fourth in, and we get integral of cosine fourth minus cosine sixth times sine x dx. And this is an obvious candidate for u substitution in the same way we did in the previous integral, because you've got cosine x in there raised to some powers, but we've got the derivative of cosine of x basically on the outside. Okay, so cosine, if we take u equal cosine x, then du is minus sine x dx. So we need to add the minus sign on the outside, and you get the integral of minus the integral of u to the fourth minus u to the sixth. Integrating term by term, we get minus 1/5 u to the fifth plus 1/7 u to the seventh plus c. And then we just back substitute. We had u as cosine x, so you get minus 1/5 cosine fifth x plus 1/7 cosine seventh x plus c. And that's it for this video where we started with powers of trig functions. Next time we'll consider odd powers of cosines, and we'll look at tangents and other powers of trig functions.